Okay, today we're talking about Chapter 7, Section 1, the square root property and completing the square. Alright, so what is the square root property and completing the square? Well, let's begin with the square root property, and we'll go ahead and snip all of this. Alrighty, so looking at looking at this, one moment. Alright, sorry about that. So looking at this particular problem, if we have x squared is equal to 81, we know that we can subtract 81 from both sides, factor it because it's a difference of squares, and we end up with a positive 9 and negative 9. Okay, but we could also do it another way, and the other way is, let me screw this up just a tad. The other way is to just simply take the square root of both sides, right? So instead of having x squared is equal to k, or in this particular up here was x squared is equal to 81, then we could take the square root of both sides. Well, the square root of x squared is just going to be x. The square root of k, we're going to take the positive and negative components of it, though. Okay, and that makes sense, right? Because if we take these square root of 81, right, we have to take the positive and negative components of the square root of 81, and that's how we get positive 9 and negative 9. And of course, we see that down here in our square root property. We take the positive of the square root and the negative of the square root. And we can also write it as plus or minus the square root of k. All right, so let's look at some examples. All right, so this reads, use the square root property to solve the equation. Okay, well, this particular problem, we have to, first of all, we need to isolate the x, as always. So by isolating the x, we're going to have, or well, it's not x, actually, it's a p, sorry. So by isolating the p, we're going to have p, all right, well, I got to fix my screen. Goose bouncing. That might do good. Okay, so p squared is equal to 9 divided by 4, right? Because I'm dividing both sides by 4. Okay, well, if I take the square root of both sides, and let's actually move this a little bit over to the right. So we've got 9 fourths. Okay, so if we take the square root of both sides, okay, on the right side we have to take the positive and negative components of it, right? So the square root of p squared, again, well, that's just going to be simply p. And then it's going to be equal to plus or minus, what is the square root of 9 fourths? Well, the square root of 9 is 3, and the square root of 4 is 2. So plus or minus 3 halves. Okay, and real quickly, this we know can turn into the square root of 9 over the square root of 4. Okay, and that's how I end up getting this. The square root of 9 is 3, the square root of 4 is 2. And I'm just going to go ahead and keep the arrows there. All right, so more of the same here. Use the square root property to solve the equation. Well, let's first subtract both sides by 75. Okay, so if we subtract both sides by 75, we end up with a 3x squared is equal to a negative 75. We're going to divide both sides by 3, so we're going to have an x squared is equal to negative 25. Next, we're going to take the square root of both sides. And again, let's, well, no big deal. And we're going to take the square root of both sides. So we're going to say we'll go ahead and rewrite it like this. X squared is equal to negative 25. If we take the square root of both sides, we have this, and then the plus or minus the square root. Well, we know the square root of x squared is going to be x. All right, well, what about the square root of negative 25? Well, we know that we can take the I out of that, right? So we're going to end up with a 5i. So plus or minus 5i. Right, so this particular problem, it's looking a little more complicated, which really sucks because this is the segue into completing the square, which Um, bad news, you're not going to like completing the square. I'm just going to tell you now, you're not going to like it, so just be prepared. But with that said, let's go ahead and move on. We have w plus 3 quantity squared is equal to 20. Well, the first thing we need to do is take the square root of both sides. So by taking the square root of both sides, we'll just go ahead and write it as w plus 3 is equal to plus or minus the square root of 20. Okay, we're not even, no need to just rewrite it. We can just do the first step there. And then of course we subtract 3 from both sides. Actually, before we subtract 3 from both sides, let's go ahead and reduce that square root of 20. We know the square root of 20 can be rewritten as 5 times 4, right? Which we know can be rewritten as, well, the square root of 4 can be taken out, so 2 on the square root of 5. Okay, so let's go ahead and rewrite the right side to look like that. So w plus 3 is equal to plus or minus 2 on the square root of 5. Right. And then the last step we'll have to do, we're just going to subtract 3 from both sides. So we're going to have w is equal to a negative 3 plus or minus 2 on the square root of 5. All right, so it's not abundantly difficult. We're just taking the square root of both sides. Make sure that when you take the square root of the right side in this particular case, you put the plus or minus in front. Ooh, sorry about that. And like I said, this is a segue into the completing the square. Now, the textbook is going to go about completing the square. Well, actually, this first exercise is pretty handy, so we'll actually go ahead and do it. But as far as the algorithm is involved to solve the completing the square problems, I'm gonna do it a little bit different from the textbook, and hopefully you'll like it. I've used it every year I've ever taught, and it's just the way I do things, and it's worked. Alrighty, so before we get to this problem, let's go back and see what completing the square means. Alrighty, so solving quadratic equations by completing the square. So in example 3, we use the square root property to solve an equation where the square of a binomial, right, the binomial, two terms in there, was equal to some constant. So the square of a binomial is the factored form of a perfect square trinomial. We know that, right? So w plus 3 quantity squared, we know is going to be w squared plus 6w plus 9 because it is a perfect square trinomial. Because again, it's w plus 3 quantity squared. Well, a perfect square trinomial, as you see, in this particular case, x plus 5 quantity squared is x squared plus 10x plus 25, and so on. Okay, and so looking down here, we see that the the third term and the middle term they have a relationship. Okay, now it might not be abundantly obvious right now, but that relationship is just half of the middle term squared. Okay, so let's see what that means. So looking at the 25, well, what is half of 10? Well, that's 5. 5 squared is 25. Okay, easy. Negative 6, what's half of negative 6? Well, that's negative 3. Negative 3 squared is 9. Okay. Negative 14, half of negative 14 is negative 7. Negative 7 squared is 49. So we see the relationship there. Okay, so let's put that into practice with example 4 and looking at the relationship. Okay, so we're just going to look at the b value, right? It's ax squared plus bx, plus bx plus c. We're just looking simply at the value that is in front of the x there, right? So looking at a, well, it's 12. It's a positive 12. Well, what is half of 12? Well, half of 12 is 6, and 6 squared is going to be 36. Okay, so that is what this n value is 36. And let's go ahead and put n is equal to 36 to avoid any sort of confusion. B, well, it's a negative 26. What is half of negative 26? Well, that's negative 23. I'm sorry, negative 13. And then negative 13 squared is 169. So we've got n is equal to 169. I have unfortunately picked up the hiccups, and this has never happened before. So hopefully it doesn't get too bad. But anyways, we're going to look at 11. Well, what is half of 11? Well, we've kind of run into a little bit of a problem, okay? We don't necessarily know, we don't know, I mean, we know what half of 11 is, but we're not going to use decimal forms, okay? Instead, what we're going to do is we're going to say, well, half of 11, we're just going to say that's going to be 11 halves. Nothing wrong with that. I mean, that's perfectly okay. And so that's what we're going to use. Okay, and so far what we've done is we have halved that middle term and then squared it. So all we're going to do here is just, we halved it. It's 11 over 2, and then we're going to square it. So we're going to end up with 121 over 4. And that is indeed going to be what n is equal to. And then d, let's go ahead and erase all this, is a negative 4/7. Well, now we're going to get, I'm going to say complicated, but a little more complicated, right? So we have a negative 4/7, so we're going to take half of it. So how do we take half of it? Well, if we did this, we say negative 4/7, and then we take half of it. All right. So we can do it. Well, I won't say do it like this, but from here we know that we can rewrite it rather as negative 4/7 divided by 2, right? Or we can rewrite that as um, or we can write that as times 1/2, right? Because we can multiply by the reciprocal, right? So now we end up with a 4 over 14. So we end up with negative 4 over 14. Or, in other words, can be reduced to a negative 2 over 7. Okay. Well, that is finally taken care of the middle term halved and squared. That takes care of that. Well, not even squared yet. Sorry, that takes care of the middle term halved, not squared. Well, if this is the middle term halved, right? Again, it's just negative 4/7. We split it in half. We divide it by 2, which we know we can multiply by the reciprocal, which is 1/2. And then from there we get negative 4 over 14, which we can reduce to negative 2 over 7. Well, now all we have to do is just square the negative 2 over 7. So that's going to be, well, what is 2 squared, which is, that's 4, and 7 squared is 49. And of course, it's not going to be a negative number because a negative number times a negative number is always going to be a positive number. Okay, so this is just a quick little exercise to kind of get you prepped for completing the square. So without further ado, let's go ahead and get into completing the square. All right, now I'm going to snip these notes, go ahead or snip this and go ahead and put it in the notes. But like I said, I'm going to do this just a little bit differently. And of course, you're more than welcome to follow along with this particular algorithm, or you can do it the way I'm going to be doing it. Right? And, I mean, honestly, they're kind of the same. I'm not doing anything radically different here. So here's what we're going to do. We're going to do what I call the zeroth step, right? And that's just going to be my formula, b halves quantity squared. My first step, what I'm going to do is I'm going to substitute my b in. My second step, what I'm going to do is I'm going to go ahead and do my division by 2. And then my third step, I'm going to do my squaring. Okay. So this reads, solve by completing the square and applying the square root property. All right, well, before we even complete the square, what we need to do is we need to put the constant, the term with just the number on one side. All right, that's one thing. And two things, we need to make sure that we have a 1 right here in front of the x squared. And conveniently for this particular problem, we do. Okay, and of course we won't necessarily have that for a problem later on, but that's fine. All right, but we have a 1 right there in front of the x squared, and that's okay. So let's go ahead and rewrite this as x squared minus 6x, and that's going to be equal to a negative 13. Okay, so again, all I'm doing here is I'm going to go ahead and I subtracted 13 from both sides. Okay, so again, I need to have a 1 right here, And we'll see what I mean by that later on in another example. And I want to make sure my variables parts are on one side and my constants are on the other. Okay. So when we do this, we're going to put in a -6 in here for b. Just make it white. -6 in here for b. Okay. And again, the whole point of that is because, well, we're just substituting for b there, right? So -6. Well, -6 divided by 2, and let's make this blue. So -6 divided by 2, that is a -3. And then a -3 squared is going to be equal to 9. Okay. So notice how I'm color coordinating here. It's very important because I'm going to show you exactly where and why things are the way they are. Okay. So I completed this square, so all I have to do now is I can rewrite this problem as an x squared minus 6x, and then we're going to say plus 9, and that's equal to a -13. Well, if I'm adding 9 to the left side, then I must add 9 to the right side, right? I have to, otherwise it won't be even, right? So I did that. Next, what I'm going to do is I'm going to factor the left side. Well, by factoring the left side, it's not that hard. I mean, I could do it in my head, but this my algorithm I did, it makes it a lot easier. We can say x and then look in the blue color -3. So it looks like step 2 is always going to be going there. And that's equal to, well, -13 plus 9, that's a -4. Okay. Just like that. And now we have a problem that looks pretty similar to example 3, right? Where we have the binomial squared is equal to some number. So we have a problem that looks pretty similar to example 3, and of course we can solve it from there. And we will. But again, notice how I color coordinated what I did here. Okay, and if you want to, I wouldn't necessarily suggest it right now anyways. If you wanted to, you can kind of skip writing this part. Okay, you could probably go from this point to this point, but make sure you add 9 to both sides. And the next example, I'll show you what I mean by that. But right now, we're just gonna do it the nice, slow, simple way. And then from here, like I said, we just solve, and it's pretty simple from here. So if we take the square root of both sides, we end up with an x minus 3 is equal to plus or minus the square root of -4. All right, well, the square root of -4 we know is 2i, right? So and we add 3 to both sides, so we're going to end up with an x equal to 3 plus or minus 2i. Okay, and there we go. We solved this problem by completing the square. All right, so let's do another one, and then we're going to skip that middle part just briefly, like I said on the last example. Of course, we'll circle back to it though. But again, like I said, what I do every single time, I wrote my 0th step, and that is just simply going to be my formula: b halves quantity squared. Step 1, well, I'm going to substitute that b, right? So I'm going to leave that blank, the b blank. Step 2, well, I'm going to divide by 2. Probably don't need to put that there. Divide by 2. Sometimes I put it there. Sometimes I don't need it there, though. And then step 3, I'm going to go do my squaring. Well, in this particular problem, we already have the constant on the right side, right? We have the 3 on the right side. But I did say we also need to make sure that what's in front of the squared portion is a 1. In this particular case, it is a 2. So what we must do is divide the entire problem by 2. And that's not hard. If we divide the entire problem by 2, I mean, basically just divide each individual term by 2. Well, 2 divided by 2 is 1, so we're going to have m squared. Let's try that again. M squared. And then plus, what is 10m divided by 2? Well, that's just going to be 5m is equal to, what is 3 divided by 2? Well, that's just going to be 3 halves. Okay. And, oh, darn it. I'm going to erase this because I really want to remain consistent with all my notes that I write. So just give me a second. Let me rewrite this. Okay. All right. So what is my b value here? Well, it's just gonna be this 5. So I'm gonna put a 5 up here for b. Okay. And what was the second color? I did blue. Okay. Well, what is 5 divided by 2? Well, unfortunately, that's just going to be 5 divided by 2. All right. And then what is 5 divided by 2 quantity squared? Well, we just square the top, which is 25. And then square the bottom with 2, which is 4. So 25 over 4, if I can fix my 4 up a little bit, it'd be better. There we go. All right, so what I said is we can kind of skip that middle step, and this is what I mean by that. We can now write the left side as m plus 5 halves quantity squared is equal to 3 halves plus 25 over 4. Okay. Now, if this is confusing, I'm only going to explain this once because, like I said, I don't typically want you guys to go too fast right off the bat. But let's go back on the previous example and explain what I'm doing here. Okay. So in order to complete the square, like we said, we had this plus 9 and we added 9 to both sides, right? Well, by adding 9 to both sides, we made this left side here a perfect square trinomial, which when we factored it, turns into x minus 3 quantity squared, which happens to be that blue number there, right? All right. Well, this negative 4 was the, uh, shoot, I forgot the word for it. Not the product, was the sum of, um, well, I guess it'd be a difference, would be the difference of negative 13 and 9, right? So I did the math there, negative 13 and 9, to get negative 4. On the next page, what I did was I went ahead and I just, on the right side, I did 3 halves plus 25 over 4. So I added step 3 to the right side. And on the left side, I did the 5 halves, which is step 2. Okay. Now, if that's confusing, no big deal. Like I said, the more you do this, it's like everything in life. The more you do it, the more familiar you get with it, and the more you're like, okay, so this I can do this instead of doing it the long way. Okay, but for now, I'm going to go ahead and erase all this, and we're going to go ahead and resume the long way. So we have m squared plus 5m. We're going to add 25 over 4 to both sides. And again, keep track of my color coordination here. All right, well, the left side I can factor pretty easily into m plus 5 halves. And I say factor pretty easily because my number here, I have it in step 2. Right? Now, admittedly, if you were to ask me right now to factor that in my head, I mean, I probably could, pretty easily. But like somebody who's just starting out, somebody in your situation, you would look at that and you'd be like, no, I don't feel like doing that because I don't like fractions. I'm not dealing with fractions, right? But it's pretty easy because you have that step 2 there. And then of course over here we need to combine like terms. Well, 3 halves. If I rewrote 3 halves with a denominator of 4, it would be 6 over 4, and 6 over 4 plus 25 over 4 is 31 over 4. Okay, so again, I got a common denominator there of 4, and then I proceeded. Well, from here, all we're going to have to do, we just do the square root property, right? So we're going to take the square root of both sides. So we're going to have m plus 5 halves is equal to the plus or minus square root of 31 over 4. Well, the square root of 31 over 4, I can split that up into the square root of 31 over the square root of 4, which is going to be the square root of 31 over 2. So let's just go ahead and write that. Square root of 31 over 2. Okay. And then we can go ahead and add 5 halves to both sides. So we're going to end up with a m is equal to 5 halves plus or minus the square root of 31 over 2. Oh, all right, and well, that's it. That's we completed the square, and I don't think there's anything else I need to say about that. Just again, you're more welcome to follow along with how the book goes about completing the square, or like I said, I mean, I've just used this my entire life and it's just worked. And on top of that, it tells you what the factored form is, and so you don't have to waste too many brain cells there to try to figure that out. Okay, so two more. Oh, this looks like a doozy. Okay. Okay. All right. I see how we're gonna be today. All right. So solve by completing the square and applying the square root property. So we're probably gonna we're have to clean this up for a moment, but real quick, let's go ahead and put my algorithm in. Okay, so I went and put my algorithm in. Now I said we're gonna have to do some cleaning up, so let's go ahead and begin this process. I'm gonna go ahead and distribute the 2x. I'm gonna distribute this 2x over this binomial there, so we're gonna have a 4x squared minus 10x. That's equal to a negative 30 plus 6x. All right, so let's go ahead and yeah, let's go ahead and put the x's on one side. So we're going to end up with a 4x squared. And then we're going to subtract 6x from both sides. We're going to say minus 16x. That's going to be equal to a negative 30. And yes, this is looking pretty bad. But let's go ahead now, and we said that we had to have a 1 right here, right? So let's divide this entire problem by 4. And um, yeah, I knew that was messed up. I knew there was a fraction in there somewhere. I messed up my arithmetic because this should not have been a negative 10. That should have been a negative 20. Negative 20x. And so with that, if that's a negative 20, then it's going to be a negative 26. Yeah, there we go. So, I mean, same thing. We're going to have to divide everything by 4. And by dividing everything by 4, this ends up being an x squared minus, well, 26 over 4. We'll reduce it here in a minute. And that's equal to a negative 30 over 4. Okay, so I said we'll reduce it here in a minute, so we're going to reduce it and put it at the very top because that's how we work things out, right? Top to bottom. So we have, for this problem, we have x squared minus, well, 26 over 4 can be reduced to 13 over 2x, and that's equal to negative 30 over 4 can be reduced to a negative 15 over 2. Okay, so this problem, like I said, is a doozy because we got fractions everywhere. And as I've mentioned, I don't like fractions. I probably hate fractions more than you do, honestly. I've dealt with fractions a lot longer, but it's not a race. But let's go ahead and begin. So what is my b value? What's a negative 13 over 2? Well, this is getting a little cramped up here, so negative 13 over 2. Let's make that 2 a little bit better, over 2. Okay, well, it's negative 13 over 2 divided by 2. So it's going to be negative 13 over 4, but how do I get that? Well, we have negative 13 over 2 divided by 2. We know that that's the same thing as saying times 1/2, right? Times 1/2, and that's how we get negative 13 over 4. So we have negative 13 over 4, and negative 13 over 4 squared. Well, 13 squared is 169, and then 4 squared is 16. Okay, so continue. Oh no, I messed the colors up, Sherman. Why would you do that? That's not too bad. I forgot what did I do. Blue then red. I keep forgetting that. Okay, so blue, oh, so it was negative 13 over 4. Negative. Dadgummit. Alright, so it's not that I can't write threes, it's just that this program doesn't like little minute movements. I know I've said that before, but I feel like I always have to say that. That way nobody's sitting on the other side of the screen saying, hey, this guy can't write a 3 to save his life. Alright, so here we go. This left side now becomes x squared minus 13 over 2x, and then plus 169 over 16, and that is equal to a negative 15 over 2. And then if we added 169 over 16 to the left side, we must also add it to the right side. Okay. Now, here, again, I'm going to be honest with you, at least this time. Well, I mean, I'm always honest. That's not the point. But anyways, if you said, hey, Sherman, factor that, I'm going to be like, no, right? Uh, but that's the whole point of why I like to do this algorithm, because it makes it so simple, because I know the left side here factors easily into x, and then I just keep on doing this color coordination because I feel like it'll really, really help you out. Boom, I just factored the right side. Easy peasy, right? And then the right side, did I say left side? I just factored the left side. And then the right side, well, we need to get a common denominator here. Well, we have a 16, so we need to make this a 16. So in order to make this a 16, we have to multiply it by 8. So we have to also multiply the numerator by 8. And 15 times 8 is going to be 120. Yeah, 120. And then it's 169 minus 120, so it's going to be 49. So this ends up being a 49 over 16. And then we can proceed. So we take the square root of both sides. So the left side is pretty simple. It's an x minus 13 over 4. That's equal to plus or minus the square root of, well, this is pretty easy, right? Because the square root of 49 over 16, that is the same thing as, since 49 is a perfect square and 16 is a perfect square, we can just simply say it's equal to plus or minus, well, square root of 49 is 7, the square root of 16 is 4. So plus or minus 7/4. And then of course we're going to add 13/4 to both sides. So we're going to say x is equal to 13/4 plus or minus 7/4. And of course this does break off into two separate answers. I guess I'll go ahead and write them out. So, and I guess that's what makes the problem so much longer, if I recall. I remember those arrows, so I'm gonna go ahead and write arrows. So if we did one of the solutions was 13 over 4, it'd be plus 7 over 4. Well, 13 over 4 plus 7 over 4 is going to be 20 over 4, which is equal to, I'll just write 20 over 4, which is equal to 5. And then if I did 13 over 4 minus 7 over 4, so that's 6 over 4, which is equal to 3/2. Okay. And so that concludes example 7. And yeah, like I said, I knew those. I remember seeing arrows there. And then lastly, we're going to be solving a literal equation. I think it's pretty funny. Just the wordage there. Solve a literal equation. Well, I mean, we are in math class after all. Alright, so ignoring air resistance, already the problem sucks. The distance d in meters that an object falls in t seconds is given by the equation d is equal to 4.9 t quantity squared, where t is greater than 0. Solve the equation for t, do not rationalize the denominator. Okay, well, I mean, we just have to solve for t. So I'm going to divide both sides. Yeah, I'll write it the way it's written, I guess. So d over 4.9 is equal to t squared. Okay, so all I did right away was divide both sides by 4.9. But I'm just going to go ahead and rewrite this like we know, right? I'm going to go ahead and write this as t squared is equal to d over 4.9, right? It's nothing out of the ordinary, nothing extraordinary, right? I just switch sides. Okay. Well, I know that I can now I'm sorry, take the square root of both sides. So it's going to be t is equal to plus or minus the square root of. I see why we're saying a literal equation now. Okay, so this would be a. Let's move this over so I can put an a somewhere. Okay, so again, I see now why they're saying a literal equation because if we solve for t, which it's wanting, we solve for t like this. Um, it's saying t is equal to plus or minus our formula here. Well, here's where the literal equation part comes into play. We are actually only going to take the positive component of this particular function because, well, as you may be aware, negative time does not exist. So my solution to a is going to be t is equal to the positive part of the square root of d over 4.9. That's not terrible. That's all right. I understand now. All right, these textbook authors, they surprise me every now and then, especially this textbook. There's been lots of typos. Anyways, using the equation for part A, determine the amount of time required for an object to fall 500 meters, round to the nearest second. Okay, so all we have to do here is just simply put in 500 for D. So we're going to have T is equal to square root of 500, right? That's the distance, 500 meters over 4.9. And unfortunately, gravity on Earth isn't nice and well rounded, so I'm going to have to do some calculator work as opposed to just simply dividing by 5. So it's about 10.1. Okay, so it's going to take about 10.1 seconds for an object to fall 500 meters. Right, and I believe, yes, that does conclude today's lecture.